Welcome to the Pharmacy Inspection Podcast, where we discuss topics related to sterile and non-sterile compounding pharmacy in an effort to promote compliance and increase quality. The Pharmacy Inspection Podcast is a member of the Pharmacy Podcast Network, delivering quality and meaningful conversations and discussions about our pharmacy industry and the critical role pharmacists play in our healthcare systems. Learn more at pharmacypodcast.com. Please welcome your hosts, Brian Prince and Seth DePasquale.
Hey, thanks for joining us again on the Pharmacy Inspection Podcast. My name is Brian Prince, and joining me always is my co-host, Seth DePasquale. We are joined today by Brenda, Jensen, and Jim Hack. They've been a previous guest of ours. They're wonderful people. They're some of my favorite consultants in the industry because they bring a wealth of knowledge to this industry. So it's always a pleasure to have them on. Today we're going to talk about this issue called viables. This has been one of those things that our audience has come back multiple times and they've asked us questions and they want us to talk about their certification reports. And so because it's not in my sweet spot, and I know that Seth has written a blog about it, we still wanted to invite guests on that we know that are very intelligent. So before we get started and ask them questions and jump knee deep into this conversation, I'm going to drop back and let Brenda and Jim tell us a little bit about themselves and how they evolved in this industry.
Thanks, Brian. Jim and I are both pharmacy technicians. We started our careers together as pharmacy specialists in the U.S. Air Force in Homestead, Florida. I've been involved in compounding one way or another since then, except for a short period when I owned a non-compounding retail pharmacy. Together, we've helped over 250 pharmacies in 45 states improve compounding quality and safety. In addition to consulting, I also fill in as a pharmacy technician in a critical access hospital in South Dakota once in a while.
Hi, Brian. This is Jim. I started working with Brenda in 2013. Like she said, we worked together in the Air Force together and learned a ton there. I got involved in oncology and nuclear pharmacy for a few years, just taking things as a little business entrepreneur and tried to find ways I can help people and learn and go every day. So, it's just from, like Brenda said, from being out here for the last 6 years of working in consulting with her, we've seen a lot of stuff and just learn every day of how to help, make it work. That's, to me, is the hardest problem. And I specialize in workflow and trying to make compliance actually work.
That's a great response. And I appreciate, again, you two joining us. So before we kind of get knee deep into the weeds on the viables, first, I tell you, let's ask a very topical, very basic question. Let's start by just reviewing the requirements for viable air sampling.
Sure, I'll take that one. Viable air sampling is required as part of the commissioning and certification of new facilities and equipment, following any service of facilities and equipment, and as part of recertification every 6 months. It is also required in response to identified problems, including issues with compounded sterile preparations, personnel work practices, or patient-related infections where the CSP is being considered as a potential source of the infection. Viable air samples need to be collected in each ISO area under dynamic operating conditions using a volumetric sampling device that collects a sample size of 400 to 1,000 liters of air. High-risk level compounding requires the use of two media, TSA for bacteria and MEA or another suitable fungal media. All growth needs to be identified to at least the genus level and the results reported in colony-forming units or CFU per cubic meter of air. Jim and I recommend 1,000-liter samples for a more accurate representation of growth. Let me explain this. If you do a sample in your ISO 5 PEC and have anything greater than 1 CFU, it's a failure. So if a 500-liter sample is taken and 1 CFU is identified, this seemingly passes, but the results must be reported in CFU per cubic meter of air, so per a 1,000-liter sample. The raw result of 1 CFU per 500 liters must be reported as 2 CFUs per 1,000 liters, so this fails. But in reality, the sampling device only captured 1 CFU, so if a 1,000 liter sample were taken to begin with, this may have passed. In the buffer room, 10 CFU are permitted. If a 500 liter sample is collected, anything over 5 CFU is a failure due to the correction factor. This is not usually an issue in the ante room where 100 CFU are permitted. This is often where another issue comes up. Per 797, highly pathogenic microorganisms, including gram-negative rods, coag-positive staph, molds, and yeast, must be immediately remedied regardless of CFU count. It would be extremely difficult to grow out 100 CFU that did not include at least one of these.
So a couple of things you said there that I think are interesting. So one thing that I think trips up a lot of people is dynamic conditions. And what is dynamic conditions? I feel like there's, when certifiers come in, we just kind of hide off in the corner and we maybe look in and check on them, see what's going on. But are they actually doing dynamic conditions? Well, I have a certifier that I use. He's a microbiologist. His name is Doug Hawes. He's excellent. He's been doing this for years and years and years. He was, the head of the Department of Health for the state of Indiana at one point. He really knows this stuff. And what he does for dynamic conditions is he'll go in and take maybe 3 different samples, 3 different times, and he'll literally do like shuffle his feet, open the door, or walk past the sampler. Now I know I'm talking about, I'm starting to get into particle counts. I'm veering away a little bit from the Bibles, but the point being is that like it's a true dynamic condition. He's simulating things that would occur when somebody's in the room. It's not like a technician going in there is just going to stand there with their arms crossed while a sampler is running. So I like the fact that you pointed out specifically that it's dynamic conditions. And then the other thing that I have a little bit of a bone to pick with the USP is the whole idea of this objectionable organisms or highly pathogenic organisms. And feel free to comment on this when I stop. But when you're making sterile products, it doesn't matter whether or not something is highly pathogenic. Highly pathogenic can be anything that's injected directly into an immune compromised person. I think that, and typically when you're in the hospital and you're getting injections, you're dealing with a lot of immune compromised people. So I really wish that the USP would recognize that anything can be really highly pathogenic. That's not to say that we have to worry about every single bacteria, but we sort of do when you're dealing with sterile products. It doesn't matter whether it's highly pathogenic or not. But so that's all I kind of have to say about that.
Okay, let me follow up on a couple of things here. So for the dynamic operating conditions, we recommend that personnel are simulating their most strenuous processes so that we get a true representation of what's going on under the most strenuous times. And so that would include the maximum number of personnel that are normally in the room and any equipment that they might be using, like repeater pumps or that sort of thing. But everything would be simulated, so nothing that's made during that time would be dispensed. And then to follow up on the highly pathogenic microorganisms, I agree that this has caused a lot of regulatory issues because of the wording. 1 CFU of a highly pathogenic microorganism is a failure, and it's really easy to get 1 incidental CFU. That doesn't necessarily mean you're going to have a contaminated CSP. The good news is the proposed revision of 797 eliminates that. So let's hope that that stays that way in the final version when we see it published in June.
Yes, that would be nice.
Yep. Hey, so let me ask you a question. This is actually a very common question. What are some of the common areas where viable growth is detected?
All right, Brian, I'll take that one. This is Jim. Brenda and I see a lot of stuff. Most of the places we're seeing, or the common area for the growth, is going to be in the ante room because there's more people in and out of that room. If we sit there and look about how we go in and what we do, we'll talk more about this in the future here, but it's people are, we're particle generators. If we're going there and we're standing around before we clean and do what we need to do and guard properly, we're spewing stuff everywhere. So we're putting a burden on the clean room, which going to the point of, for me, I want you and everybody else to understand, how does your equipment work? How does your clean room work? To me, the clean room is a piece of equipment. If we're putting more burden on it, can that room handle what we're doing? Or do we need to put less burden on it by having a flow and a system that works, that we know the equipment can handle and do what we need it to do? The problem is there's so many poor clean room designs out there that it becomes a major issue. Think about it when they design clean rooms. You think about the placement of the HEPA filters, the vents, the air returns, all that's critical. Look at many of them have the sinks on the opposite wall from entering the clean room. So now I'm going to have to walk ungarbed all the way through the length of that ante room to go scrub and garb in my ISO 7 environment already. That's pretty tough. We shed particles and we do stuff over there. If a pharmacy is doing high risk level compounding, you're more than likely going to have a powder containment hood in that ante room for weighing and mixing. If we do that, think about that. I'm going to walk not only to the sink, but I'm going to walk by that powder hood ungarbed on my way to get garbed and do that. Powder hood draws in the air from the room. That's, it comes out through a HEPA, but again, we're putting what burden or what unnecessary burden on that piece of equipment. And then we need to test and see if it's actually working and do what we think it does. The second issue is, go ahead, I'm sorry.
I was going to say, you absolutely nailed it. I tell people when they're laying out rooms, it really becomes a chess match, right? Which means that if I'm planning on putting my hood here, say an autoclave here, a pump here, a process, and I've got doors swinging here, I've got a sink over here, and I've got all of these different parts, all of these different Lego pieces, even where I place the fan filter units in relation to the workflow model. So to me, the workflow model, you nailed it. You absolutely nailed it. The workflow model is absolute to understand. Anybody can design an in and out clean room, put fan filter units in the ceiling, but it's understanding the process, understanding the players, understanding the equipment, understanding everything that's going to happen within that environment, and not crossing past. I saw that the other day. I saw where to get to the hand hygiene sink, somebody had to walk right by the powder hood, again, mostly ungarbed, all the way to the other side of the clean room. And they just weren't thinking about the process. And so I'm sorry, I'll park and let you finish your sentence from earlier.
No, I'd like to do this. It's fine because we see that all the time. And I think that stems from not something that people intentionally do, but if we own a pharmacy, we hire somebody that knows what they're doing. So they build us a clean room, but they build a clean room and then we put all of our stuff in it and change the design of the clean room. And I don't think the actual owners and the techs and the pharmacists in that room understand that the room worked perfectly until we started putting us and everything else in it. And now we've changed that room. And I think we need to educate and have more understanding of that in the future to make sure what we think is really doing, is it really working? Is it doing what we think it can give us the results on? Another one is the inadequate or lack of garbing. I mean, so often do I see a technician in there working and a pharmacist going in to check something or ask something and open the door or walk in. Or I was only in there for 5 minutes, but 5 minutes of what? Shedding of whatever you had on you from where you came, what you brought into that room, spewing it all over. And again, that would work great if we designed a room that we knew was going to do the 12 air exchangers or the 30 air exchangers or whatever is required to clean that out and make it go. But so many times we see that, whether the room worked before we put equipment in or not, it's changed the room right now. and it's not doing what they think it's doing. We're putting more risk on everything we're trying to do. And our technicians will run in and out. They forgot something. They'll go grab something and come back in.
Yeah. So you're saying not understanding the workflow model, and then the layout is actually what is the main contributing factor to where the viables are showing up. Are you putting a correlation with those two?
I am. As a technician, you don't really understand enough except for what you're doing and how to use the hood, how to turn it on, how to clean it, how it works a little bit. Some people are obviously on different levels, but the average technician in there working knows how to go in there and do the job that Brian wants me to do and clean up and go out, but they don't understand more than that. So if we've changed by moving equipment, adding another, think about putting a whole nother hood in a room. How does that change that room? Technicians, we were never taught that kind of stuff. So to learn and feel and go, it's really tough.
Yeah, and that that you've given me a perfect segue into the next question that I had written down here in front of me is because there's not really a clearly defined guidance on a sampling plan. What do you recommend? How do I develop? How would I develop a sampling plan?
I got that. Let me finish one more. I just want to tell one more thing because it bothers me. Another thing is the lack of staging products in and out into our clean room. We don't ever think about where the product came from, and then we don't stage it properly or don't stage it at all and bring it into our room, when in reality you would think that the room would handle that and be able to clean it off enough for us to not have any issues. But again, we're putting more burden and more stress on that room and the equipment than it's needed. I mean, we need to wipe some stuff off and stage it going in. USB tells us we need to stage from the anteroom to the buffer room and then again into the hood. We recommend that we stage it from the unclassified area into the anteroom, because look at that. It's stored in, somebody's warehouse, from the manufacturer to a warehouse to us, and it goes straight into our room. And we think about cleaning it off once it's in the anteroom to go into the buffer room, but now I'm cleaning all that off in my anteroom. Why do that?
Yep.
So I apologize for going back on that, but one of those things I see that I really need to do.
And I was just saying, let me comment on that. So exactly what you said about staging, like staging is my hot button, right? And I like to teach staging more so for non-sterile, but you hit it definitely on the sterile side as well. So I was at a pharmacy, and again, this was a new build out, so it wasn't a fully operational clean room, but I had two pharmacists and a technician. And I said, hey, tell me, because we were talking about, where to garb in, where to garb out. The sink was in a certain area. And I said, all right, well, tell me what I'm carrying. And they said, okay, you're carrying a plastic tub. And I actually was miming. I'm miming it now, but you can't see me on the other side of the radio or microphone. And I said, okay, all right. So I've walked in the door and I've got this plastic tub. Now I need to do, I need to put on my head cover, or where do I put this tub down? They're like, well, okay, what if we had a table right there? I said, okay, now I have to cross over to where the sink is to get to that table. Is that the best use of that? Okay, so let's drop back and let's rethink this. And so we stepped A, B, C all the way through the process. And then actually what we did is we moved the location for one of the fan filter units because, number one, it was in conflict with the airflow, the exhaust airflow coming out of the powder hood. And number two, it was not close enough to the sink where I was starting to stage and garb and do hand hygiene. So again, it's a chess match. It is an absolute chess match. And I'll park there because I don't want to get up on that high horse and let you talk about mapping out a strategy.
I agree with you. I mean, another thing we could talk about this for a whole show just on this. You and I can do this, but think about the negative pressure rooms though too. If these things aren't sealed and closed up properly, they're going to pull things in and they're going to have viable problems there too. Particulate problems, and things come from ceiling tiles, outlets, light switches, sprinkler units. I know you see that, but we see that all the time. But going on to your question on mapping, USB says that an appropriate environmental sampling plan shall be developed on all compounding activities performed. It's kind of gray, right? So selected sample sites shall include within the location, right? ISO 5, your PEC, and then the ISO 7 and 8 areas, wherever the greatest risk of contamination, work areas, hoods, counters, doors, pass-throughs, sinks, anything like that, so we can keep track of what's going on. The plan should include sample location, method of collection, frequency of sampling, volume of air sampled, and time of day as related to the activity in the compound area and action levels in that location.
I kind of like the idea of running this like an experiment, and you kind of hit the nail on the head when you said risk. So where are our riskiest places? You know, obviously the PEC is one. What about places like where we put stuff when we're going into the clean room, maybe on shelves or tables? Door handles is another thing that I suppose could be thrown in there every once in a while, maybe to see if that is a risk. But I think that there needs to be a little bit of experimentation done at first to get to the sampling plan. You have to go in and actually sample to maybe see where your hotspots are. And I think to go back to your earlier point, it's knowing about the process. What am I doing from A to Z and everything in between? And where am I putting things? Where am I staging things? Where are the places that are a potential risk in my process that I want to figure out a way to mitigate it? One way to mitigate it is obviously through, environmental sampling and then figuring out what to do as a result of that sampling. But I think risk is the key to all that. That's the biggest part of this whole conversation. It should all be based on risk.
Yeah, absolutely. Good call there, Seth. So the last question I have, it's if we're looking at a certification report, and I feel like that certification reports are kind of one of those thorns in my side because they're not standardized. They're not like a safety data sheet where I always know that section 11 is always going to be the same toxicology and I have that and I know what I'm looking at, right? Nobody has standardized that. And I don't know that with the certification industry will ever get to that point. Maybe they will, maybe they won't. But what parts of the certification report really should we pay attention to as it relates to this topic?
It's important to remember that your viable air results may come back to you separate from your certification report. So you may end up with two different documents. Okay, so the actual certification report should include the sample locations, volume of air sampled at each location. Some regulators like to see the start and end times for each sample. It should also indicate that sampling was performed under dynamic operating conditions like we talked about earlier. The report should also include the types of media used, media lot numbers, and expiration dates. Remember that high-risk level compounding requires the use of two media, TSA for bacteria and MEA or another suitable fungal media. These incubate at different temperatures, so the report should include incubation time and temperature as well so that you know it was incubated appropriately. A negative control should be included so that you know the media wasn't contaminated before the testing was performed. The certification report should also include evidence that the equipment used to collect the samples was within its calibration date. When you do receive the results of the viable air testing, make sure that all growth is identified to at least the genus level. Also ensure that the results are reported in CFU per cubic meter of air. Double check that growth does not exceed action levels or meet the definition of a highly pathogenic microorganism. Even if you do not exceed action levels, it's important to look at the types of microorganisms that were detected. Micrococcus and coag-negative staph are often associated with human shedding, so may indicate inadequate garbing. Remember that 797 is a minimum standard, so additional garbing may be necessary. Cladosporium or other plant fungi may be carried into the clean room with air currents or on personnel clothing. We have seen this as a problem with clean rooms where the anteroom entrance is in the same room as an exit to the outdoors. Activities immediately outside the anteroom entrance can also negatively affect the air quality in the clean room. In this area, it's best to avoid excessive particle shedding activities and storage of corrugated cardboard. Plants and animals should also not be permitted in this area. If you do exceed action levels, 797 says an investigation into the source of the contamination shall be conducted. Sources could include HVAC system, damaged HEPA filters, and changes in personnel garbing or work practices. The source of the problem shall be eliminated, the affected area cleaned, and resampling performed. The first step in this process would be to evaluate the remainder of your certification report and compare it to previous reports. Look at non-viable air samples, air changes per hour, pressure differentials, and HEPA filter integrity. Does the viable air growth relate to the areas with highest non-viable particles? If so, what activities are occurring in this area? Consider the airflow from the HEPA filter to the exhaust and the possibility that there may be an area that does not get good air circulation. Air change requirements listed in 797 are minimum. More may be needed depending on the number of people and activities that are going on in your clean room. If the air changes have decreased significantly from the previous report, this may indicate the need to replace a HEPA filter, or in clean rooms with adjustable vents, a vent may have gotten moved. If the latter happens, pressure in the room should increase. Make sure certification personnel verify that pressure gauges are reading accurately. Finally, ensure that certification personnel are checking the integrity of HEPA filters. Ideally, this should be performed through an injection port. We've seen viable air failures when certification personnel have removed a ceiling tile to test HEPA filters, then perform viable air testing afterwards. It's best to perform viable air testing first, starting with the cleanest areas, so PECs, buffer room, then the ante-room. Keep in mind that it is not required that certification personnel perform viable air testing. This may be done by qualified personnel in the pharmacy and may actually avoid some of these potential contamination problems from the certification people.
Cool. Thank you so much, guys. I just want to ask one last question. It's kind of one of my parting questions that I typically ask, but you guys have any other pieces of advice that you want to impart on everyone on the specific topic that we're talking about today? Any last words?
The most important thing is to not just trust that your certification company has told you everything or reported everything accurately. You need to trust but verify. So you do need to go back and read those reports and make sure that whatever you do grow doesn't meet the definition of the highly pathogenic organism or exceed any of those action levels. Because just because it passes doesn't mean there are issues that are going on, or some of that stuff you can be proactive and maybe catch before a problem starts. For example, if your air changes per hour start decreasing rapidly, you want to address that before you get down below the minimums and have problems starting up.
Jim, I know you've got some parting advice. Once we get you started, it's hard to get you to be quiet.
We don't have enough time for that. The biggest thing I could do, it's simple. There's things that we can do to help the room and help the equipment by being more knowledgeable of our room and our equipment. But it goes down to the simple things of washing and garbing properly and knowing that, am I going in that room to do something, or, I guess you just need to limit the burden on the room by our flow and our work and triaging better and understanding how the room works so we don't stress it over its limit.
Yeah, I think that education, and again, we probably say the word education more than any other word here on the Pharmacy Inspection Podcast. But you said it earlier, is that these are things that we don't learn as technicians. We don't typically teach as, a regular training module in our pharmacies. And so does everybody need to know how the intimate details of every HVAC happens? No, not at all. But you do need to know operationally how things interact with the room. Does the autoclave does it create a moisture source, and is it near a doorway? We just need to, I think, all kind of step back and kind of rethink some things. And again, I'm probably the world's worst. Once I get in a habit of doing the same things over and over, it's hard for me to take my own personal blinders off and not see the things that I need to be seeing. And that's probably where I think the parting advice is for me, is to say, okay, let's kind of take the blinders off and rethink, because USP is making us get, I think, better at who we are. There's probably a lot of people that say, well, it's making it difficult. It's making it more tough. And I can't disagree with that. But the reality is that if we keep pushing and raising the bar, as we like to say here on the podcast, we will make the environments in which we work and we produce product for our patients, we will make it so much better. And so I appreciate you, Brenda and Jim. Thank you for joining us. It's always a pleasure to have you with us. And please feel free to be a regular guest, because we want to extract all of that knowledge in your brains and give it to our audience. Again, we have that open source mentality. So thank you again for joining us. And we hope to talk to you guys again in the future.
Thanks so much for having us.
Thank you for having fun. Appreciate it.